All right. Here's our deal. That doesn't even look like 8.5 by 11. But anyways, the maximization problem, you're supposed to kind of work with it as if it was a 8.5 by 11 sheet. And what you're supposed to do is that you were going to kind of like cut out some little squares, right, at every corner, because those were going to get folded up to create a box. Yeah. So once you did this. Okay, and we don't know what those lengths are. We're going to call it XX, XX, XX. Let's hope this kind of works for me here. So I have that, and when you folded up the edges, you're supposed to end up with something that kind of looks like a, don't fail me now, 3D eyesight. Oops. I was going to use my finger. That doesn't work. That's not funny. So, close enough. So it kind of looks like a box once you fold up those edges with heights of x, correct? Yeah. So what we wanted to do is to find the volume of the box where you can fit the most stuff. It's the maximum volume, correct? Yeah. Well, let's think about this. If we want to find the maximum volume, then we need to use a specific formula, don't we? And which formula is that? Volume formula. If we want to maximize volume, then doesn't it make sense that we use the formula for volume? So, if we want to find the volume of, we'll just go sub B for box. Is that cool with everybody? I know that I've got to multiply three numbers, don't I? Okay. One is definitely going to be this height, which is x, correct? And then I have to get this length. Now, how long is this? Well, originally, how long was it? It's 11 inches originally, correct? Yeah. But we took away this little piece, this little segment, which is x units long. But we also did it on the other side, didn't we? Yeah. So that becomes 11 minus 2 x's. Everyone agree? Cool. This algebra at work here. Hiya. So this is now 11 minus 2x. So I have my length. What's the other component I'm missing here? Which is the width, correct? Yeah. Length, width. So this originally was 8.5, correct? Yeah. But again, I took away some pieces, didn't I? And what did I take away? 2x. I took away 2x. So there's that one. So if I take this times this times this, that should be the volume of the box, correct? Yep. Now here's the beauty of algebra, is because we did not use specific values, we left in an unknown x, we have created a function. Okay? So now we have the volume of some box in terms of x, which means this will calculate the volume of any box once I pick x. So if I say, well, you know what? What if x was 0.5? Then you plug that in, and then you get the volume, don't you? Which actually was the first problem that you had to do on your little chart. And you said, well, what if x was 1? And then you calculated that. What if x was 1.5? And you calculated that. And you got a bunch of them, didn't you? Right? The beauty of a function is I can do all of them in one sweep. So what I want to do is I want to find the maximum of this. Does everyone understand this bit? Okay. Now, let's do this real quick. I'm going to go to my 100 calculator. And I'm going to, oh, that's statistics. JK smiley face, LOL. Hey, why don't you go away? Go away. He didn't like me. They wanted my sweet caress. You guys are so quiet, I love it. Well, not really, but. I want to, how do I do this? Zoom, second window, man. I'm going to reset my calculator. Is that cool with y'all? I want to go back to all my defaults because I don't want you guys to. Okay, cool. So, why? I'm going to throw that function in here. You guys ready? Okay. So the function reads x times let's see here, 8.5 minus 2x. Go ahead, someone say it. 8.5, thank you. Oh, what the heck? 8.5 minus 2x, close parenthesis, times 11 minus 2x, close parenthesis. Okay? Now, everyone understands that we could have sat there and we could have foiled it and we created one polynomial, right? But that's too much work. So there it is. Now, if I take a look at the graph, then I could be able to look at the max, can't I? Hey, where'd you go? Ah, there it is. There's my graph. Did I do that right? X times 8.5, x, cool beans. So, there's my graph. Cool? Be able to maximize that? Okay, realistically, let's see here. If I kind of, see here, move up. Why aren't you moving? Oh, it's Tracy, my bad. I want to zoom out. So 3, let's zoom out. Oh, this isn't very helpful, is it? Okay. Oh, there's a graph. Oh, it's not even at the top, am I? So let me hit zoom again. There it is. See it? Find it. Exactly, huh? Okay. Now, so again, now this is simply, I'm making a point, is that you have to be able to use your tools to the best of your abilities, okay? Now, obviously, we know we don't need the whole function, do we? All we're looking for is a maximum point. So what I want to do is I want to go back, and let's think about some constraints here, okay? What numbers are we going to choose for x? What numbers make sense for x?
I'll go with 2 since I was young and good down. So let's go with 2.
What's the smallest x that I can put in there?
0.
Well, I can't put 0 in. Because if I had 0, then would I have a box?
0.1.
So that means that x has to be greater than 0, correct? Because I could have 0.1. Because if it's 0, do I have a box? No, I've got a plane. And I mean not a plane like, I mean like a plane like, yes. Okay. All right, cool. So everyone's okay with that, right? Now what about the largest value that I can put in there? What's the largest value that I can put in there? Well, let's think about this real quick. I know that originally this side was 11 and this side was 8.5, right? So if I fold it to where it's about 4.25 and I fold it there, am I going to get a box? If I said that x was 4.25, why? What would happen again? I would simply be folded in half, wouldn't I? So do I want to pick anything higher than 4.5? Sorry, 4.25? Do you guys see how, is this making sense to you guys? Good, good, good. So I want to make sure that x is less than 4.25 in order for me to be able to have a box. Because think about this. Let's say I did pick 0. And I plugged it in there. Well, what's 0 times anything?
0.
So this would give me 0 volume, wouldn't it? 0 volume. Well, what if I picked 4.25? Well, when I put 4.25 in there, guess what would happen with that as well? How much volume would I have then? 0. Okay? So what I need to do is I need to make sure that when I'm looking at my graph, I'm looking at some specific areas. Do I really need the whole graph? No. What do I want to look at? I want to look at the area from 0 up to about 4.25, maybe 4.3. So let's go back to my calculator. And let's change the window. Oh, look at that. No wonder it's crazy, huh? So let me go to my window. What do I want to do? What do I want to do? Help me out. My minimum. My x minimum is going to be 0. What's my x maximum? What do you guys want that to be? 4.25? How about 4.3? Just a little bit over? So that way it's in the window. That works too. But we could also do 4.25 because I know that 4.25 doesn't even matter, does it? Why? What happens at 4.25? How much volume do I get? Exactly, I get 0 volume. Now, what about a y minimum? What is y representing here? The volume. Can I have negative 160 volume? Why? If I take it out, if I take stuff out, isn't that negative volume? No, that doesn't make sense. So what's the smallest volume that I'm looking for here? 0, right? I mean, that's as far as it can go. So I'm going to go 0 here. And let's go ahead. You guys want to leave 160 or do you guys want to try something else? What's the maximum? Well, I guess that's not a good question because that's what we're looking for. You guys want to leave 60 and then adjust if necessary?
Yeah.
Does that sound good? Okay, so I put those values in. I still want my y scaling to be by 1, so let's take a look at the graph here now. And bam! I got the important part. I got what matters now. Can you guys see here? When I have 0, how much volume do I have?
0.
And how much volume do I have at 4.25?
0.
And what starts to happen is I start to increase. And how many people thought you were going to get a maximum at 2.5? Or what is that, 2 or 3? Okay, so now we can actually figure out how to get, because it's going to be some point up here, isn't it? Okay, so that's our job, is to figure out what that point up there is. So I'm not going to make you guys do it by hand. We're going to use our handy dandy calculators. And it goes like this right here. There's a trace feature here. I'm going to show you that real quick. So if you trace it, I can see that as I move it, my volume is increasing, isn't it? So 61, 62. Did that jump? It did jump up, didn't it? 63, 63.5, 63.9, 64. I could do that, and I can sit there and be like, and I see how I'm getting closer and closer. That's one way of doing it. Or I can use the second feature for trace, which is to calculate. And you're going to go second, calculate. And which of those do you think I'm looking for? For maximum. For maximum. And here's it's going to ask you 3 questions. What is the left side of this maximum? Well, the left side of the maximum is, and it doesn't matter where it goes as long as it's on the left side somewhere. You understand that? So somewhere about there. And where's the right side? So what it really wants to know, what you're doing is you're helping the calculator so it doesn't check the whole function. Does that make sense? Okay. All I want you to check is the area from between here and there. Okay? And then it's going to say, take a guess at where it is. You're helping it again. Well, I think it's right about here. Hit enter. And it's going to tell you exactly where it is. So, bam. So there's the maximum volume when x is 1.585. That would give us the maximum volume. Pretty simple, huh? Sure. All from the volume formula.
So why would you maximum volume?
Yeah, so when x is 1.585, this is the maximum volume that I can get in there, which is 66.14 inches cubed. Pretty sweet? Now, here's the thing though. You're not in your uniform. Okay. Now, yeah, you guys can go. All right, cool. Any questions on maximization? No, CC, huh? Yes, no? Okay. Here's another question, though, for you. Another question for you, though. I was looking at this function. I'm going to zoom out a little bit. Let's see if I can zoom out real quick. Is that the only time I'm going to get this volume? No? Is that the only time I can maximize this volume? Is that the only time that I can get 66.34 for a volume? No. Do you guys remember the function? Let's see here. It kind of did. What did I do? Let me go back to standard. Zoom 6. Hallelujah. Okay, and what I want to do. Actually, you know what? Window. I want 0 here, and I want 0 there. Graph. It's going to come down. It's going to come back up. Okay. Come on, get up there. Man, I got to go to the way 66. Let me go change this again. Window. I'll be lazy. My Y scale, I'm going to change it by 10. And let's try to get graph. What am I missing? Oh, my Y max. How far up did the volume go? Okay, so I'm going to go 70 then. Come on, you got to work for me now. Boom, there it is. There's my max. And then it goes down and it comes back up, doesn't it? So, again, when will it have the same volume? Well, doesn't Y represent volume? So if it's at this point, is that the only time it hits that? No. So can we do this another way with a different X height? God, I'm just asking some random questions. I want you to think about those. Ashley, you're saying yeah? Can I get another maximized instead of just using the 1 point blah blah blah? You know what? Turn to your neighbors and talk about that. Okay, have that discussion with them because I think you guys are scared of me right now. Turn to your neighbors, have that conversation. So.
I don't know why it's doing this, but whenever
Because there's a staff law.
For some reason my calendar or my graph has a picture of it.
Oh, sweet! I just realized something, yeah. Shaman? Oh, shaman, like a shaman. I hope you like shaman too.
Because I've been turning them. It's just a test. It's like frozen.
Call me on the cell phone.
That was 2019.
I don't have an explanation for that, but I have a feeling. Yeah. I have a feeling.
Guess who's not going to share the explanation?
Oh, there it is.
She said she had a duty head. Truly, you're
I know, right?
You're fucking
Okay. So, who's my guinea pig? I gotta pick on someone that I've never picked on before.
You picked on me.
I see Mia over there hiding under her hand. So Mia, what did you guys come up
Mia,
with?
her name's
Mia, Leah, what?
Mia.
What am I saying?
Mia.
And what's her name?
Mia.
You're saying it was
Oh,
an
that's
N.
right. I'm sorry, my niece is Mia, so every time I see yours, I really think of my niece. So that's how near you are to me. What am I saying? And what did you say? What am I saying? Go like el chavo. ¿Y cómo dice? ¿Y cómo se dice? ¿Y cómo dice? All right, Nia. What you got, girl? No what?
No.
Are you like refusing to answer?
No, I said you can't reach maximum height twice.
Maximum volume?
Oh.
The function tells me I can. I said that, didn't I? See, this is a max volume here. And this volume is actually here again.
But it's
Yes.
And truth be said, I can actually get more volume than that. So, Miss Quintana, you were saying something?
Nothing, I'm sorry.
Shoemaker?
No, since that's out of 4.25.
Absolutely correct. Okay? What the funk is it? Funk? I shouldn't have stopped there. It sounds like what the. Oh my god, that was horrible. What the function is saying, all it's doing is mimicking the behavior of the box. But that's if we had unlimited movement with, to the left and to the right. But we don't. Okay, we're confiscated to the size of the paper. Okay, remember that's why we created the constraints over here. We said, you know what? X can't be any smaller than 0, but it also can't be any bigger than 4.25. Because if we did 4.25, then it'd be like folding the paper in half. So it has to be somewhere between those. So even though the function is saying, hey, you know what, you can do it again, no, not true. Because once you've crossed 4.25, you can't, like...
That's the fourth dimension.
Yeah, it'd be weird. So, that's it. Maximization. Questions? Yeah?
Wait, is your like on your calculator, how would you put in like the function?
How do you put the function in?
That's how we originally went X.
Y equals.
Oh.
Right there.
You're right, the equation. Oh.
It's right there. Okay? So, let me go and stop this because I'm going to give you an assignment. Yeah?